Hello, welcome to this video on implementation of queue in C language. As we can see, this is a queue of people. The queue has two important points, the head and the tail. The first in the queue is the head. Of all people shown here, this lady has come first. The last person in the queue is the tail. The last person has come most recently. The first person in the queue, the head, is the one who gets serviced. After service, she goes off the queue. As the first person gets serviced and she goes off the queue is a first in, first out data structure. This is a queue of people. You might as well have queue of jobs, a queue of any kind of entity. Now we will develop a program in C language to implement the queue. Our program will have three commands: enqueue, dequeue, and print. Enqueue adds an element to the queue. The element is added behind the tail, and the tail points to the newly added element. Dequeue gives an element from the queue. The element at the head of the queue is given, and the head points to the next element. The print command prints all the elements in the queue sequentially from head to the tail. Let us start thinking about the design of the queue program. What are the requirements from the data structure? The data structure should provide a way to store queue elements sequentially. There should be two pointers that point to the head and tail of the queue. Should we use array as the data structure for queue? Here is an array of 10 elements. There are two variables head and tail which store the array index for head and tail respectively. This is an array of 10 elements. So we can have a maximum queue size of 10. There is a limitation here. The queue has a maximum prefix size. You might think of having a large prefix size, but it would be a waste of memory. And if you have a prefix size, on some odd day, the queue will get bigger than the prefix size. Secondly, if the queue is empty, what are the values of head and tail? For empty queue, head and tail are not defined. There should be at least one element in the queue for head and tail to have valid values. So you have to keep track of whether the queue is empty or not. Thirdly, suppose the queue becomes full with head at 0 and tail at 9, and the person at the head goes off the queue. Now head is 1 and tail is at 9. The next person joining the queue will be at index 0. Now the head will be at 1 and tail at 0. So you have a situation where head is behind the tail, and you have to implement this queue as a circular queue which has involved logic. To sum up, using array as a data structure for queue are prefixed maximum queue size, keep track whether queue is empty or not, head and tail are not defined for empty queue, implement the queue as a circular queue, so possibly array is not a very suitable data structure for implementing the queue. Now let us look at the linked list data structure which we'll use for implementing the queue. There is a struct element having two members. The first member is name, which is the name of the person this struct represents. Then there is a pointer next, which points to a struct element. For each person, we have an element with the next pointer pointing to the next element in the queue. We have two pointers, head and tail, pointing to the head and tail of the queue respectively. So this is our queue with three elements and head and tail pointers. Look at the last element pointed by tail. The last element has the next pointer initialized to null. It does not point to anything as it is the last element and there is no next element. What if we make this pointer point to the first element in the queue, the head? Then we can say that tail pointer to next is head, and we can get rid of head variable. This means one variable less and a simpler program. As William Ockham said, never increase beyond what is necessary the number of entities required to explain anything. So, finally, this is our schematic for Q that we will use for writing the program. Let us look at the enqueue function. There are two cases. In the first case, there are no elements in the queue and tail is null. We equate the next pointer of the element to be added be equal to itself, and we make the tail equal to the pointer. In the second case, there are already few elements in the queue, and we wish to add element pointed by pointer to the queue. We make the next of element to be added equal to the tail pointer next, which is the head of the queue. Then we make tail pointer next, the next of currently last element point to the pointer. Finally, we update the tail to point to the element just added. Now let us look at the dequeue function, which takes an element of the queue. The element at the head of the queue is removed from the queue and given to the requester. Here the element is passed in the ptr pointer variable. So first, ptr points the same location as tail pointer next, which is the head of the queue. Then there are two cases. In the first case, there is only one element in the queue. So if ptr, which is the head of the queue, is equal to the tail is made null. And now there are no elements in the queue. In the second case, there are multiple elements in the queue. So ptr is made to point to the tail pointer next, the head of the queue. Now since ptr is not equal to tail pointer next is made to point to pointer next. And our queue is shortened by one element. It has one element less now. That ptr pointer next still points to the head of the queue is of no consequence, as we don't bother about the next pointer of ptr. We are normally interested in other fields of the element received from the queue. This is the complete program. We can compile and run this program. The complete source code and explanation is available at http://bit.ly/queue-in-c. Please like this video and subscribe to our channel. Thank you.